Hello and welcome to another video. Hope everybody's keeping safe. An update on the project. As you can see, it's now in a metal case, nice blue. It's got 3 sides coated. Take that off. 3 sides are blue, with the top, the back and the base as vented steel. On the front panel, 50 milliamp meter, loading cap, PA tune is slow motion drive built onto the actual capacitor itself, and on the VFO, which presently runs from 1.73 to 2 megs, is another vernier control, and basically a 6.5 to 1, so it's giving just over 3 turns of the centre dial to do 180 degrees. Microphone input, microphone gain, a antenna, Morse key, AM on, AM off, that disconnects the HT to the modulator and ECC83, and a Jones, or there is another name for it, can't remember, patent or pattern plug socket, keyed in one direction only, so I can put HT, LT on there. Still using the power supply from the TV, so I'm still waiting for a transformer to turn up. I've actually ordered one now, 120 milliamps at 250 volts, or 280 volts actually, to allow some HT drop on the rectifier. So this is a project progress up to now. Would I recommend this build or anything like this based on the CODAR to anybody else? And the answer has got to be no, I wouldn't. Fine if you only want to use it for one band, and I'll talk about this later, but not trying to use it as top band and 80 meters. I'll go into details in a little while. Plug it back in. I shall apply power, put it into a 50 ohm load, and let you see the HT increases quite a bit when I'm not driving the modulator anymore. So that means to say the power can go up quite a bit. Right, 2 seconds, let me connect things up. Okay, at the moment I've got it powered up. It's in CW mode without the Morse key at the present time, so that gives it permanent power. Let me just put in the Morse key. There we go, that kills the cathode connection on the PA valve. So, key up, there's the anode current now standing about 45-46 milliamps, and the output power is showing at about 8 watts. That's because without the modulator and ECC83 powered, the HT rises. I've probably got about 270 volts on that, and so probably about 14 watts input there on that. Make sure it's decked, and I am getting, oh no, it seems to peak there, and it's about 8 and a bit watts. Now if I drop it into AM mode, obviously the power is now applied to the EB6BW6, get it right, and the ECC83. So the HT drops, the power drops, and I'm getting back to what I had once before, just under the 6 watts. So that's probably, as I'm running 40 milliamps in, and that'll be more to 250 volts HT, that'll be 10 watts input. No, can't quite get 6 watts. So drop the power off that, and drop the HT off. My thanks goes to Ian G4JQT, who wrote an article for the Practical Wireless magazine in 2010. He posted the article on the UK Vintage Wireless forum, where we've been discussing the build here for the AT5 clone. So I've used Ian's circuit and a bit of warning text that'll be shown a little bit later. If you've noticed, I've highlighted L3 and C9, which is between the EF80 buffer and the grid of the PA valve, the 6BW6. In this configuration it acts as a notch filter, with the filter being L3 and C9 plus any anode capacitance from the buffer valve and input capacitance of the PA valve. What I've actually done during testing is put in a tunable coil and a trimming capacitor instead of those two components. That allows me to tune it between the fundamental frequency and the third harmonic, and you'll see why in the next few pictures. On this first image here, all I'm doing is tuning all up on top band, 1.9 megs-ish, and the carrier and any spurious are quite clean. It's showing as 40 dB down for any signal that's coming out on the 80 metre band, which is comparable to some of the other amateur radio kit that's around today. On this next image, I've tuned the PA to be 80 meters output. Now this is without L3C9, and you can see that at the present time the fundamental is only about 20 dB down on the 80 meter carrier. There is a third harmonic which is 30 dB down on, which is 5.7 megs, and the fourth harmonic, which would be the 40 meter band, it's greater than 40 dB down. So on this image I've tuned the notch filter to be on the third harmonic, the 5.7 megs. The fundamental is still 20 dB down on the carrier, and the others are now around about 40 dB down, an improvement apart from the fundamental still coming through. On this final image I've tuned the notch filter to be the fundamental, the 1.9 megs. It has reduced it to 30 dB down on the carrier, and the third harmonic, which is the 5.7 meg signal, is 35 to around about 36 dB down. This, in my own little mind, is not quite good enough. And as noted by Ian in his article, the fundamental and harmonic suppression is not that brilliant when it's compared to modern day standards, and this has also been echoed by a few others within the forum mentioning AT5s that they've got as well. So what next for the transmitter? I can either leave it as it is and just purely use it as top band or 160 meters. The other options are to stick a second VF4 coil in and see how stable it would be on 80 meters. Or a third option is to leave it as VF4 on top band and add a crystal socket, so I can use 80 meter top band and do some tests to see if I'm going in on 80 meters from the VF4 or crystal, if it remains as a clean output. Thanks for watching. Catch you again.